So this question is partition list. So you're given the head of the linked list and the value x. So what you need to do is whatever the node that is less than the x, the node that value is less than x, that you want to put on the left side, and whatever that is greater or equal, you need to put on the right side. So you want the partition is such that all nodes less than x comes before nodes greater than or equal to x. So this is pretty straightforward. So we're starting from here, and then when we want to traverse, we want to make sure is the current node is part of the small linked list or the large linked list, right? So if this is 1, which is less than 3, then I know, oh, this node is part of small, right? So I will just say, oh, small has node 1, and then I move my pointer to here 4. 4 is greater than 3, so I point it here, and continue going on. Moving 4 to 3, and 3 is definitely greater or equal than x, and continue, and then 2, 5, 2. So this is how you get it. And then when we want to when we finish the traversal, what we need to do is we need to point the last value, the last node in the small linked list, to the large dot head, and the last one, large dot, the node in the last one in the large linked list, you need to point at null, so that you know this is the end of the linked list. So you definitely need a pointer that point at the current small node index, and also a pointer that is always represent the head of the small linked list. Same thing for the large. So you have a large head, and also a pointer that point traverse based on the large index. So what we need to do is, okay, so I will have a list node small head equal to new list node, and then I will say large head, and I'll create another one which is going to be small equal to small head, and also another one large equal to large head. So this is pretty straightforward when we want to initialize the linked list. And then while the head does not equal to null, I will definitely need to compare the value if this is less than x or larger than x, right? Or larger equal to greater equal to x. And if this is less than x, which is part of small, so you will do the small dot next, which is going to be equal to head, and you need to move your pointer for small to the next value, which is going to be represent empty, because every single time you initialize a pointer, you initialize a node, you have an empty next, and then this will be the same thing, but you're going to have large dot next equal to head, large equal to large dot next. So every single time you're going to move your large and small, one of them to the next one, but before you move, you need to point at the current head, and everything at the end you need to increment your pointer for the head. And then when we finish the traversal, we know the last value for the small, which is going to be point at the large one. So it's going to be large head dot next. The only thing why we are not using the large head is because large head is initialized to empty, and then we're using the large to be the pointer. So if this is like the first one in the large head linked list, right? The large will definitely initialize dot next to the head, not the large head. So large head is a placeholder, which is like small head as well. Same thing for here. So large dot next, you need to initialize to, you need to set equal to null, so which is the end of the linked list. and then you will definitely need to return the small head .next, because small head by itself is placeholder. .next is actually how you move it, because small is point initial point is small head, which is nothing, just as a constructor, and then you're using the small .next to point at the head. So this will be everything for the solution. Okay, so the time and space is straightforward. This is the space all you need. You are actually just pointing at a node for every single time, which is partitioned small or large. So technically you are not declaring declare all of n node in the linked list. You only, this is size of pointer, right? So it's constant for the space. This will be the time you need to traverse every single one of them to make sure every single one of them is part of small or large. So all of them for the time, constant for the space. All right, see you.